It's been a snowy, windy, and now rainy Saturday here in Sitka, Alaska. And just outside the studio here, I can see a family of ducks riding the tumbling dark gray ocean in a single file line, in almost perfect sequence. Speaking of sequence, today's Mariculture Minute continues our exploration into paralytic shellfish poison.
And then we introduce some radioactive saxitoxin. Yeah, tritiated. So it's pretty benign. I think it's less than the bananas at the grocery store, I've been told.
It's not going to cause any turtles to turn into ninjas.
No,
okay.
I haven't developed lizard eyes yet, so I think it's okay, yeah.
That's Shannon Cellan. Shannon's the environmental lab manager at the Sitka Tribe of Alaska. In the last episode, we discussed how shellfish can collect neurotoxins that can cause our muscles to get numb and in extreme cases stop us from breathing. Scary stuff. Side note, if you ever eat some shellfish, a clam, mussel, or oyster, and feel a tingling around your lips, go to the hospital. But Shannon helps people know if their shellfish is safe. She tests for paralytic shellfish toxin. I asked Shannon what excites her about her job.
How real world it is. I think sometimes science is so behind closed doors. Even when we are out in the world doing field sampling, right? It's research for the sake of research and knowing, which is great. But getting to meet people who utilize our resource and knowing the tribal environmental staff who are going out weekly or bi-weekly and collecting their shellfish and then bringing it to us to keep their community safe. It's just so cool. It feels so valuable, and I'm grateful to get to be a part of it.
In this episode, we're going to talk about testing for paralytic shellfish poison. It's shellfish smoothies, pig brains, and some radioactive stuff. So snap on your goggles, sterilize your suppuratory funnels, and get out the graph paper because it's lab day. Here's Shannon.
So we get the shellfish in from all these communities. We have people fill out a form because we obviously want to be able to track. It would be really unfortunate if we mixed up people's shellfish and gave people the wrong data. So lots of paper trail stuff going on. But once it comes in, we shuck the shellfish and then we homogenize those minimum of 6 individuals to get that representative sample from the beach or from that harvest.
Let's talk about a couple vocab words. The first is shuck. That's when you take off the shell of the shellfish, like opening up a clam to get out the soft stuff inside. Shannon is talking about shucking the shellfish to get the stuff inside ready for testing. And here's what it sounds like to shuck an oyster. First, I put a knife into the hinge. That's kind of like the point in the back where the shells kind of meet. And since I'm using a knife, kids, ask your parents for help. Then I can get a little leverage to open the shell and work the knife around the new opening to cut the oyster's muscle away from the shell. And I can open it up. The second vocab word today, homogenize. This is a word I hear all the time and have no idea what it means. I looked it up just now, and it's when you take more than one liquid or liquidy substance. They might be a little chunky, and you mix them in a way that they're nice and smooth and uniformly distributed. A nice, even shellfish goop. It reminds me, check out my Instagram Kelp Show for my latest smoothie recipe. So we'll return to Shannon. The lab is taking at least 6 individual shellfish. Shannon shucked them and homogenized them.
Once it's homogenized, we're going to extract the toxins. So paralytic shellfish toxin is caused by a suite of toxins. Okay. We often hear of like saxitoxin. Okay. It's saxitoxin and other toxins that look and behave a lot like saxitoxin. They have like slightly different, bringing in some chemistry, slightly different functional groups. So they're going to bind in our body a little bit differently.
We talked about saxitoxin in our last episode. It's a toxin that can, in some cases, stop us from breathing. Sometimes it's in our shellfish.
Yes. So I mentioned those sodium ion channels earlier. And when we take our shellfish that we've smashed up, we extract it in a super gentle acid solution. We boil it in hot water, and then we spin it really fast so that the liquid goes to the top, all the heavy organic matter goes to the bottom, and then we have this liquid solution that we should have our saxitoxin concentrated into.
Okay.
And then we can use that liquid and we run it on a 96 well plate. So we're doing all of this representative bioassay work on a little plastic plate
Like
on a benchtop. Yeah, which is pretty cool. Yeah.
In case you've never seen a 96 well plate, I'm looking at images online and they kind of remind me of clear egg crates if you were to get 96 eggs in a package. And the eggs were really, 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 really small. It looks like the plate can fit in the palm of your hand. The 96 well plate also reminds me of a popsicle tray. Basically, it's a rectangular shape with 96 circles that are like little cups to hold liquid. We also heard the term representative bioassay. A bioassay is a process that uses something that is alive or was alive to test for something toxic. Classic example is a canary in a coal mine. Back to Shannon. We have our shellfish smoothie. It's been boiled, spun around, and liquid is on top. We put that liquid in the wells of a 96 well plate.
On that plate, there's a bunch of wells, and in that well, what we're going to do is we're going to mix our shellfish extract, and we call that our wild saxitoxin as well, because we're trying to look at how much saxitoxin would be incurred from the sample itself. And then we introduce some radioactive saxitoxin. Yeah, tritiated, so it's pretty benign. I think it's less than the bananas at the grocery store, I've been told. And the reason we do that is it has, so it's called a receptor binding assay, and we're going to create competitive binding.
Okay.
So basically like musical chairs is how it was explained to
Awesome.
me. Yeah, and they're going to compete for spots because we're going to also introduce some smashed up pig brain.
Okay.
So it's very scientifically sent to us in little vials from Millipore Sigma, but it's basically just mushy pig brain solution.
Okay.
And those sodium ion channels.
To briefly recap our last episode, we're talking about sodium ion channels. This is a chemical process in our bodies, particularly our neurons, and paralytic shellfish toxins like saxitoxin can block the sodium ion channel. And when a toxin blocks our sodium ion channel, we might find it hard to move our muscles and eventually we might not be able to breathe. And what Shannon is talking about now is testing the shellfish on pig brains to see if there's anything that might block the pig's sodium ion channels.
And those sodium ion channels, pigs are mammals, so they're going to have similar sodium ion channels to humans. And those sodium ion channels are the chairs. So we're going to play musical chairs between our wild saxitoxin and our tritiated or our radioactive saxitoxin. And depending on how many of those channels are taken up by each one will give us an idea of the toxin quantity.
Cool.
So the reason we use radioactive is because it's counted on an instrument called a microbeta. It's a scintillant counter.
Microbeta scintillation counter. Did you hear that? We're deep into science now. The microbeta scintillation counter. I just want to highlight, this is an instrument that can help measure radioactivity.
And what we do is we add another solution that then excites the radioactivity. And this instrument is super good at picking up small flashes of light that our eyes can't perceive.
Okay.
So the more radioactivity in the solution, the more little flashes, the more photon flashes we're going to get. So if we see a lot of, or if the instrument sees a lot of photon flashes, that's going to mean that we have a pretty low overall toxin.
Wow.
Because most of those musical chair seats got taken up by the tritiated saxitoxin.
Okay.
Yeah. And then if we don't see a lot of flashes, so we get really low return values, It's almost counterintuitive. That means we have a high wild saxitoxin because all those chairs got taken up by our naturally incurred samples.
So, using Shannon's metaphor, musical chairs. We have the chairs set up with pig brain samples. Then we start the music. We have shellfish samples and radioactive saxitoxin circling the pig brains. The music's still going, but when it stops, the sampled saxitoxin and the radioactive saxitoxin compete for the pig brain seats. If the radioactive saxitoxin gets the seats, the level of saxitoxin in our shellfish is low and our shellfish is safe to eat. If the radioactive saxitoxin doesn't get the seats, we have high levels of saxitoxin in our shellfish, and our shellfish are not safe to eat. Is that right?
Yeah, and this is all happening in like a 10 millimeter well, 5 millimeter well. So we're putting it into these wells, and then it's like this whole reaction is happening. We let it incubate in the fridge for an hour, so we just give it time. We give everyone time to play, and then we no. Maybe though, they say if you sing to plants, maybe we have to play music for the plates and we'll get faster results.
That's it sounds like you have to be a scientist. It sounds like you can't just like taste the shellfish yourself and say,
no, yeah.
This is a high tech. This is science.
It is science, yeah. And it's so cool though because it's science that's happening in Sitka, and it's like accessible to the whole community. And I think there's a lot of things that maybe are technical, but once you're working on it, it really does make sense. And it's a pretty straightforward assay, and it's like so translatable that needing more labs, it's going to be way easier to introduce these labs into other regions in Alaska. Whereas the HPLC method, which stands for high pressure liquid chromatography, is a method we also have, and it's just very, very challenging to use. It's like very instrument heavy, very technical, compared to this receptor binding assay. And then the like gold standard method, because it was the first method produced, is the mouse bioassay.
Okay.
So you take that same slurry of shellfish that you made, and then you extract the liquid, but instead of putting it on this plate, you inject it into the space between the stomach and the skin of a mouse and time how long it takes to die, which is very sad, but also important work. And when that was the only method to keep people safe, that worked. But now we have new technology, and people are starting to try and get away from that.
Whoa! I have a lot more to explore with this topic, but I'm going to end this episode here. We've talked about how Shannon tests shellfish samples for paralytic shellfish toxins with a receptor binding assay, or RBA. And after this episode, we know what all that science talk means. This is a method that Shannon described as musical chairs. The shellfish sample competes with a radioactive saxitoxin. Notice how Shannon says how this RBA test could easily be set up around Alaska. But did you hear how full of science it was? Some people say that all you need to do to test shellfish is touch a little bit to your lip, and if you feel a tingling, it's bad. That sounds really dangerous when you think about how much science just went into this test that we described. It sounds almost like you could be making a deadly mistake. So, testing is important, and we'll get into it even more in our next episode. We'll talk about other forms of testing, particularly how the state of Alaska tests for paralytic shellfish toxins for commercial shellfish. We're talking oysters and the like. And previously I promised to peek at a mystery. We ran out of time this time, but we'll definitely get into it in the next episode. If you visit me at kelpshow.com, I'll include a list of vocabulary words from today's episode and links to Shannon's lab at ctor.org. You can see the data they collect and learn how to submit shellfish samples yourself. Special thanks to Alaska Sea Grant, University of Alaska Southeast Sitka Campus, Professor Angela Bowers, Aldo Griffo-Hahn, Sarah Ebersol, Brenna Hackinson, and a very special thanks to Walden Murphy for supplying the music for this episode.